Hello everyone and welcome to the lecture on Amazon SQS Simple Queue Service. So Amazon Simple Queue Service. So SQS is a fully managed queuing service offered by AWS. Message queuing service. It is designed to facilitate communication between distributed systems and components. Asynchronous communication. SQS allows systems to operate asynchronously by passing messages between them. Two types. SQS offers two types of queues, standard and first in first out FIFO. Use cases of Amazon SQS. Decoupling components. SQS allows architectural decoupling by storing messages from the sender until the recipient can process them. Distributed systems. It facilitates communication in microservices, distributed systems and serverless applications. Load balancing. It can be used to distribute workloads across multiple resources. Data consistency helps in maintaining data consistency across services and systems. Advantages of Amazon SQS. Highly scalable. SQS can handle a large number of messages, allowing it to scale with your business needs. Reliable. Provides durability by storing messages across multiple servers. Secure. Includes features like encryption and identity and access management for secure messaging. Cost effective. You pay only for what you use without upfront cost. Limitations of Amazon SQS. Message size limit. Messages can only be 256 KB in size, requiring larger data to be handled differently. Visibility timeout. After a message is read, it is invisible to other consumers for a defined period, potentially causing delays. Limited operations. SQS has a smaller set of message-related operations compared to other messaging solutions. Latencies. In some cases, there can be latency delay in message delivery, especially for FIFO queues, first in first out queues. Key concepts in AWS SQS. So first is queue, a temporary repository that holds message until they are processed. So just think of it like a broker or something where you put your items and that it gets, so producers and consumers will wait for these items. So producers will send a message to queue and consumers will pick up from the queue. Next is message, the unit of data that is sent between service via a queue. Producer and consumer, the entities that send, producer and receive, which is consumer, receive messages. Visibility timeout, a period during which a message remains invisible in the queue after being read. Okay, now standard versus FIFO queues. Ordering. Standard queues don't guarantee order. FIFO queues maintain the order of messages. Duplicates. Standard queues might introduce duplicates while FIFO queues don't. Throughput. Standard queues offer nearly unlimited throughput. FIFO queues have rate limitations. Next, polling methods. Short polling. Returns immediately, possibly with no messages. Faster but may return empty responses. Next, long polling. Waits for a message to arrive, reducing empty responses and improving efficiency. Dead letter queue. Purpose, used for storing messages that could not be processed after several attempts. Threshold, the number of times a message can be received but not processed before being moved to dead letter queue, DLQ. Message life cycle. Send. A message is sent by a producer to the queue. Receive, the message is pulled by a consumer for processing. Delete, after successful processing, the message is deleted from the queue. SQS message size and duration limits. So we'll just go through some of the limits and some quotas. So message size limit. The maximum size of a message that can be sent through SQS is 256 KB. So this is a limit. Message retention. The messages can be kept in the queue for a maximum of 14 days. Batch messages. Up to 10 messages can be sent or received in a batch operation. SQS throughput and rate limitations. So standard queue offers nearly unlimited throughput, limited mostly by the number of messages producers and consumers can produce and or consume. FIFO queue, rate limited to 300 messages per second with batching or 300 transactions per second without batching. Visibility timeout and delay. Visibility timeout. The maximum period a message can stay invisible after being read is 12 hours. A delivery delay. Messages can be delayed up to 15 minutes before being before becoming visible in the queue. Okay, polling cost, short polling. Faster but can result in more empty responses, potentially increasing cost. Long polling, more cost effective by reducing the number of empty responses, saving on request cost. Okay, next some dead letter queue DLQ limits. First one, redrive policy. Maximum number of receives before a message is sent to the DLQ is 1000. DLQ retention. Messages in the dead letter queue are retained for up to 14 days. SQS integration with Amazon S3. First one, event notification. Amazon S3 can notify an SQS queue when new messages are created or existing objects are deleted. Data transfer. SQS queues can be used to decouple components during data transfers to and from Amazon S3. SQS integration with Amazon DynamoDB. Stream processing. Amazon DynamoDB streams can be used to trigger an SQS queue for real-time analytics. Decoupling write operations. SQS can buffer write requests to DynamoDB, thereby enabling smooth scaling and protecting against throttling. SQS integration with AWS Lambda. So, event-driven architecture. SQS can trigger Lambda functions to create an event-driven architecture. Batch processing. Lambda can process messages in batches, making it efficient for bulk operations. SQS integration with Amazon Kinesis. Real-time analytics. Kinesis data streams can publish messages to an SQS queue for real-time analytics. Data aggregation. SQS can be used to collect and aggregate data before sending it to Kinesis for further processing. SQS integration with Amazon Redshift. Data loading. SQS can queue data for bulk import into Amazon Redshift. ETL workflows. It can be integrated into ETL, extract, transform, load workflows for data transformation before loading into Redshift. Amazon SQS and Kinesis data streams. SQS, Amazon Queue service is designed for messaging queue between distributed systems, and Kinesis data streams is optimized for ingesting real-time streaming data. So this one is just a comparison between these two services because they are very closely similar to each other in terms of functionality. So SQS is more for messaging, queuing and distributed components, but Kinesis data stream is optimized for ingesting. This one is the real-time streaming data. So it's more for real-time streaming data, but this is mainly for decoupling the systems, but not for real-time streaming. Okay, both comparison now in terms of data processing. So SQS ensures that messages are processed at least once but does not guarantee order. But in case of Kinesis, it maintains order and allows data to be replayed for a certain time window. In terms of data retention, SQS messages can be stored for up to 14 days. Kinesis stream data can be stored for up to 7 days. And throughput and scalability, SQS offers nearly unlimited throughput based on the number of messages and their sizes. Kinesis, throughput is determined by the number of shards and each shard provides a fixed rate. So this is just to keep in mind. This one is totally serverless and that's why there is unlimited throughput, but Kinesis it's limited by number of shards that you create, and it's so you have to increase the number of shards if you want to get over that throughput. Okay, when to use what? SQS. It is suitable for applications that need to decouple microservices, distributed systems, or serverless architectures. Kinesis is ideal for use cases requiring real-time analytics, and for example, if you want to have some dashboarding and all. And that's all. Thanks for watching.